Good afternoon, and welcome to this webinar on the question, how is Lean Six Sigma applicable in an R&D environment? I'm Jules Attard, Master Black Belt at 100% Effective, and I'd like to thank you for spending your time here with us today. A few words about the technology before we start. And by the way, if you can see my mouth moving but you can't hear any audio, now would be a good time to tell me. Thank you. I'm going to be talking for about the next 20 minutes. You can ask questions at any time using the chat function on the left of your screen. I will answer all of your questions at the end, unless there are so many that we can't finish in the 30 minutes allowed, in which case I will answer the remaining questions online using the Twitter hashtag, which is shown on this next slide here, at hashtag 100PCBizChat. So in the next 30 minutes, what I want to do is to show you how Lean Six Sigma, which is sometimes called LSS for short, can be used to address the challenges faced in the R&D organizations today. How we can do that faster, at lower cost, and by eliminating the obstacles, create more time for our scientists and technologists to innovate. I will begin with a short overview of Lean Six Sigma for those who are unfamiliar with this method of continuous improvement. I will illustrate how it's been applied to problems in R&D departments in several different industries. And in the end, I will try to answer your questions. Whatever sector you're working in, and whatever type of product or service you're creating, your organization are facing those challenges. Innovation itself is much more complicated as we seek to offer more features and benefits to our customers. We have to adopt new technologies. We have to satisfy customers who have more demand than ever before. Our customers and shareholders are both demanding faster product development times at the same or lower cost. They also have come to expect predictability from the creative process. So we have to deliver innovation to time, to cost, and satisfying the target attributes reliably. And despite all this, R&D has also to satisfy pressures from society to comply with environmental, product safety, and competition regulation, for example. And yet we still have to be innovative. In the next 25 minutes, I hope to show you how a continuous improvement approach, like Lean Six Sigma, can help R&D organizations come to terms with these factors. So first of all, let me begin with a high-level summary of LSS, as some of you today may be less familiar with this method of continuous improvement. Lean Six Sigma is a fusion of two approaches to business improvement, Lean and Six Sigma. Lean has a focus upon eliminating waste, and by the elimination of waste, to make the process faster and more efficient by spending less time on work which is non-value adding. Six Sigma is the focus of Six Sigma is upon reducing variation, eliminating unpredictable outcomes would be another way of putting that, either in quality of output or the time it takes us to perform an activity. Both Lean and Six Sigma have a common focus on identifying and satisfying the needs of the customer, whether that customer is internal or external, and both use data rather than opinion to reach decisions. There are two slightly different flavors of Lean Six Sigma, both of which are illustrated on the slide. One of the characteristics of Lean Six Sigma as a method is that it uses a structured approach to solve problems. The two slightly different approaches depend upon whether I'm trying to improve an existing product or service, or whether we need to create something from scratch because the existing product or service cannot meet the needs of the customer even if we improved it. They're sometimes called DMAIC, or define, measure, analyze, improve, and control, or DMAVI, define, measure, analyze, design, and verify. And in those 5 stages, we define the problem so that we have a clear goal. We measure it so that we can establish our current baseline performance against the needs of our customers. We analyze it so that we can find the critical factors which we can change, make and pilot improvements, and then finally we ensure that the solution is sustainable by developing ways to control or verify the new process. Each stage builds upon the one before. So, for example, we don't rush to solutions before we find the critical root causes, so that we're sure we're actually changing the right things. Both DMAIC and DMADLI approaches are used extensively in R&D, and both can be used to develop a new product or service, as well as to work on the processes of R&D. In view of the time this afternoon, I'll only talk about how Lean Six Sigma has been used to improve R&D processes. But if there are any questions about using Lean Six Sigma for product innovation itself, I'd be happy to take any of your questions afterwards. The most commonly heard criticism of Lean Six Sigma is that it talks the language of making cars or silicon wafers. And it's true that Lean Six Sigma originated in these industries. And indeed, some of the common tools of Lean Six Sigma don't easily translate to other types of work. But I hope to show in the next few minutes that the underlying concepts, and indeed very many of the tools, can be applied very well elsewhere. At the core of Lean Six Sigma is the focus on solving customer problems, whether that customer is an internal or an external one. We use a logical DMAIC or DMADLI structure to solve our problems. We use data to reach decisions, and we check the validity of our data before we trust it. We use a blend of skills from different people and functions to achieve success, so that different perspectives are brought to bear on the problem. These are all principles of the scientific method as well. So it should really be no surprise that Lean Six Sigma can be used in R&D. It's using the same concepts and the same principles as we already use in our normal work as technologists. We just have to remember that we're not building cars, unless, of course, you are actually doing R&D on cars. As I mentioned, Lean Six Sigma uses a structured method of completing improvements. Each step builds on the work that was done before. But there isn't one size of project for all problems. One of the strengths of Lean Six Sigma is using different types of improvement activity appropriate to the problem. To do anything other than that would actually be to introduce waste, which was one of the things I said we were trying to eliminate. So, for example, a clearly defined problem with local impact can be addressed in a quick win or a rapid improvement event, which is sometimes called a Kaizen event. A more complex problem, which might affect more parts of your organization or incur greater risks if change takes place, may need longer to complete, and it may need support from a broader range in your organization. On this slide, I've shown some typical projects of different scales appropriate to quick wins or small or major projects that have been conducted in R&D organizations that I've been involved in. On the following slides, I will describe some of these projects in more detail. The key to success in short, quick win improvements is to tackle problems with a clear scope that can be resolved within the existing resources of the team. For example, increasing the uptime of test equipment by identifying and eliminating the cause of breakdowns. That can be achieved in just a few days, and it can quickly deliver a payback in increased test capacity and shorter sample turnaround time. A common beginning in continuous improvement for many teams is to improve the cleanliness and layout of their working space using 5S. And this is also sometimes something that can be done with very rapid payback. 5S stands for sort, set in order, shine, standardize and sustain. So first of all, we identify what items need to be kept in the workplace and we remove the ones that don't. Then in set in order, we organize the workspace so that everything has a place and we can find it quickly. In shining, we keep the workplace clean and tidy. We then establish standards which can be followed by anybody in our team, even a new member of the team. And finally, we make it a habit by sustaining it so that we don't revert back to the situation that was there before. 5S can be done as good practice in itself, or it can be done as part of a larger improvement project. Immediate benefits that come from conducting a 5S activity will be things like reduced delays looking for equipment, or less time cleaning glassware, and better safety. In the longer term, it becomes possible to quickly spot non-standard conditions and to take action before they create an unsafe event or an unsatisfactory outcome for the customer. But you can have unexpected additional benefits. In one 5S project that I worked with, a team of chemists found that over half of their reagents in the store were 5 years old or even older. By eliminating those and putting steps in place to stop that problem happening again, their work was now faster, safer, and fewer of their experiments suffered from cross-contamination issues which led to failure, and then they had to repeat the experiment. They also reduced their consumable spend by being able to find and use more of their existing stock. They had more trust in the inventory, so they didn't need to go and buy any more. It's a common need in R&D to manage with a constrained budget, and Lean Six Sigma is often used to manage the spend on consumables. This kind of project can take a little bit longer to complete because we have to gather data in order to permit analysis. And we also need to understand the consequences of changing suppliers or reducing the number of raw materials before we make any changes. In one project, a team found that in the labs they were using different purities of the same solvent. It was obviously a very easy decision to make to rationalize to a single purity of solvent, but they had to take account of the needs of the users to make sure they made the right choice, but also to ensure that the users accepted the changes and didn't undermine them later on by reverting back to their previous purchasing habits. Having rationalized the consumables down to the right materials from the right suppliers, the team then went on to look at the pattern of usage. What the data revealed was that some materials were used regularly and others were not, so they needed to find different supply strategies for each kind of material. Then they could calculate how much of each raw material to hold in their lab, how often they should be ordering them, and what should be triggering reordering. This gave them a lower overall inventory of consumables, and some of the additional benefits here were that they needed less storage space, so they could expand their operations without building new labs. They also had better availability of raw materials, so they didn't suffer project delays. In addition to reducing operating costs, this kind of project will often address one of the most common causes of project delay, which is waiting for a new raw material to arrive. By ensuring better availability of the consumables, the scientists can get their job done easier and faster. By making the resupply easier, it also frees up their time, so they spend more of their time doing value-adding work and less time ordering raw materials. It's common when creating new products or services for one piece of equipment or person, a type of person, to be critical, what I call the critical resource. The rate of delivery of a project is often limited by this equipment or person bottleneck. Lean Six Sigma helps us to identify these bottlenecks and to implement solutions which increase their availability and minimize their impact on other equipment or people. So in the example shown here, when the bottleneck is a machine, there are many well-proven approaches. Here, a technical department was supplying samples of experimental resins to prospective customers, and they found that all samples had to be made on one extrusion machine, which had long changeover time between resins and was often unserviceable due to needing repair. Classic lean techniques such as setup time reduction and total productive maintenance significantly increase the output of the machine. And by installing visual management and a pull system to manage demand, the machine was able to deliver the most urgent samples quicker. Setup time reduction is one of those techniques which can be applied to any critical equipment which loses time in the changeover between one job and another. And it does this by doing as much preparation before the changeover begins and then streamlining the remaining work. It's a very successful technique, and it's sometimes compared to what happens in a Formula One pit stop. And I'm going to hopefully show a short video to illustrate what I mean.
That is a machine.
So although working in a laboratory or a technical department is not the same as racing Formula One cars, the difference in how long it took that service to complete compared to the last time I took my car to the dealer is the kind of improvement that we might be aiming to achieve in our own setup of critical equipment. The Lean Six Sigma solutions to use when a bottleneck is a person or a type of person are not the same because people are not machines, but we can still get answers from Lean Six Sigma, which are very effective. The example here is maps a part of the process of setting up a clinical trial where you drug tested on patients. And one thing this is a visual mapping identifies is the delay between 1 and 2 while lead contracts were reissued to medical investigators. May track it to 2, 3, or even more side revision. Not only was the submission, rejection, and reconsideration of those contracts a waste, but it put more demands upon the very limited legal resources of this company. And so they very quickly built up a backlog of contracts under review, which was delaying the setup of their trial and therefore the results that they could get from running the experiment. Applying Lean Six Sigma techniques to standardize alternative contract wordings and to find other resources which could assist during demand peaks completely removed this bottleneck from the critical path, so they had much accelerated trial setups. In your research project, the scarce skill might be different. It could be a physician, it could be a polymer scientist, but the approach of identifying the bottleneck and standardizing the work and finding alternative paths to deliver the work has repeatedly been shown to generate considerable time in development projects. The project I've just described on this slide actually sounds very simple, but when you think about the number of stakeholders involved, internally, externally, third parties, you'll quickly appreciate that actually it's quite a complicated project. Completing a Lean Six Sigma project which meets the business objectives quickly requires a green belt or a black belt to have good influencing and change management skills, as well as skills of hard analytical life. In conclusion, Lean Six Sigma, well, I hope I've demonstrated today that the concept behind Lean Six Sigma are very compatible with the way R&D organizations function, and that applying them can bring enormous benefits. Faster to market, lower cost, and freeing more time to spend on value creating tasks. recognizing that the work of R&D is not usually about making cars, we've recently launched a Green Belt course designed specifically for the R&D sector. Using our blended learning approach, this course will give learners the tools to make a rapid impact in their workplaces. Please get in touch if you would like to know more about this training. If you have other interests in what you've heard today, here are some other ways you can get in touch with us after this webinar. Visit our blog, join us on social media. Please get in touch. So in conclusion, I'd like to thank you once more for your time and your attention this afternoon. I'd like to now have the opportunity to answer your questions. I can just while I'm giving an opportunity for people to type those questions in, I can see a couple of you had problems with the video during the presentation when I cut away to YouTube. This webinar is being recorded and can be replayed afterwards. The YouTube clip won't be part of that, but I will post the link to the YouTube clip on my Twitter account so that you can access it from there. One question from Alphonse Carlier in France. Don't you think that researchers will be afraid? Yes, I think that that's a great question. It's not uncommon that people are nervous when they're faced with the challenge to the way that they do the work, that they may have been doing the work in a particular way for a long time and they're very comfortable. I think what you have to show them is how a change will affect them personally for the positive, but also to understand their negative perceptions and to ensure that whatever solution you come up with both minimizes the negative impact and by emphasizing the value of the change both to them and to the wider organization, you can bring them along with it. Question here from Sharon Coughlin in Wirral. Can 5S be overdone with the R&D pilot plant environment, made too complicated? I think I agree with you, Sharon. I think 5S can be overdone. I've seen it overdone certainly in an office environment. So I think it's necessary. And if it is overdone, you won't carry the people with you. The importance of sustaining the solution is that it becomes a part of the way people do their work. If you've overcomplicated it or made it too precise and you don't allow the flexibility of the way people do their work, you might find that it isn't supported as a change. However, I would definitely start by looking in a 5S at the things that need to be done. And I think that a pilot plant environment would be a really great place to work. Chris McHugh in Runcorn asks, do you think that this type of structured approach will inhibit creativity? Thanks, Chris, for the question. It's the one that I normally get asked when I try to work with a team of scientists. I hope that it doesn't. One of the things that most scientists and technologists value is the time that they spend being innovative. Lean Six Sigma doesn't primarily address that part of their work, although there are techniques, if I talk about applying Lean Six Sigma to creating a new product, that it could be. But in the context of improving the processes that they use in their function, there's a lot of those things can be distractions from the main creative energy, the creative tasks. If I apply Lean Six Sigma to eliminate the waste of those activities, the non-value adding tasks, if I can use that phrase, then they get more time to be creative. And in fact, so there is a benefit to creativity by using Lean Six Sigma and by using this structured approach. Often the problems that we're trying to solve with Lean Six Sigma are problems that people have tried to solve previously without a structured approach. What they've actually done is that they've spent longer trying to solve them and the solutions haven't been effective, they haven't stuck. So one benefit from the structured approach is that you get to the solution quicker and it sticks, it stays in place after you've finished. David Ibbotson in Nottingham has asked, hello David, has asked, how can this be applied to a stage gate process? Thanks for the question, David. Something that in my past we used quite significantly. If I refer back to the DMADV, the define, measure, analyze, design and verify approach, this was actually used as the basis for a stage gate process in innovation. So you can apply the same thinking of what tasks do I need to do at different stages of my product development, and you can use the concepts and the approaches that Lean Six Sigma suggests as problem-solving approaches as part of your stage gate process itself. So there's a great fit between those two. I've got one question here from somebody in the pharmaceutical industry who points out that their industry is a regulated one, and they feel that it's not easy to make changes to R&D processes when they're working in a regulated environment. And I share that point of view. I recognise where that comes from. It's not, pharmaceuticals is not the only industry that's regulated. Food packaging is regulated. The financial sector is a regulated sector, and all of these are also under pressures to improve the way that they create new products and services. The regulators themselves are not actually hostile to process change. In recent years, they've in fact adopted different positions, encouraging the companies that make up their industry to be more innovative in how they do R&D. One particular example is how the FDA encouraged the pharmaceutical industry to adopt quality by design. Quality by design is one particular flavour of Lean Six Sigma that the FDA were very in favour of. So the regulators are sometimes encouraging industry to be more innovative in the way it does its work, in addition to its core business of being innovative in creating new products. I think that's brought us to the end of our 30 minutes. I'd very much like to thank you for your time this afternoon. I'm going to close this webinar now. As I said before, this webinar is recorded, and you can watch a replay at any time. And when I close the meeting, you'll be taken to a web page which gives some more details of that R&D Greenbelt training course that I described. Thank you very much for your time once again. Have a good day.